This is the second in our lecture on tables or lectures, and I would like to go over relates or joins in tables. And we need to do relates and joins because we often break our tables up. Our tables are big, and in a relational model, we break them up into their organic parts, one might think of them. And then we put them together through these joins in ways that are to our advantage. Different people want different groups of information, so we can use the joins to isolate the data, then folks can only pull in the data they want. It also makes it easier to edit because the pieces are smaller and non-redundant. You'll see that when we go through normal forms, which is in about the third lecture, on how we split these apart to get the tables in the right order and form. So a join basically is joining tables back together by a column in each of the tables. And we have to be careful in picking these columns. So here I have two tables, a forest and trails table, and I'm going to relate or join those two based on this forest ID column. So I have a forest ID column in both of the tables, and I use the values to match records. Now, they don't have to have the same name, the two columns that I join. They have to have the same type and domain. That means I can't have one be alphanumeric and the other be integer, or one be integer and one be real. But I'm not going to do that if I want to do a valid join, because I want these values to come from the same universe as these other values in the corresponding table. The other thing is the direction of the join. This shows the arrows going in both directions, but really I'm thinking of it as joining in a direction. So I'll join, in this case, in this direction from one to many. So this one matches all these ones, and I'll repeat this information every time I find a one in this column. So I'll be matching these. Then you look across and stop the video and see you can correspond each of these combinations to the join in these two tables. So this first one, getting the first column here in the forests, the first row in the forests, and it matches via the one to the first row in the trails, and the data come down here, so I get the Bryson's Knob from the trails name, and the Nantahala 1 North Carolina and size from the forests, and you can walk them down. Now, the joins are through keys. And keys are columns that uniquely identify the rows. We often use keys in building databases and tables like a student ID or a part ID or a social security number. It's something that if we know that value in the column for the key column, we know the values of all the other columns in that row. So as the reading states, a candidate key is any column or combination of columns which uniquely identify the row. So in this case, I know this number is L00, 0, 2, 3, 4, 5. There's only one of those in this whole column. And so Jim Black and C002 are associated with that student ID. So this is a key for this table. Now I can have this value, this variable, in another table, and maybe in that other table it can't serve as a key. There may be repeat values for this student ID. For example, if I have a course table that has the list of courses, I might have multiple entries for this student because they've taken several courses or are taking several in a semester. So I might have a semester table that's different, in which case this wouldn't serve. The course might serve as a key, and then all the students in it, right, would be entries for that. So I basically have to be careful to realize that this key is a key only in a given table. Now, if I want to maintain what's called the referential integrity, every time I add a row, I have to make sure I'm not violating this key behavior. I can't add another row for this student into this table. I can't have duplicate rows. And so if this is the student table, then I have to make sure that when I enter, I don't mess up the value of this as a key. So I can't put duplicates in for a given student. And the same thing for social security number in a table. I wouldn't, if I had lists attached to folks, I wouldn't want two entries with the same social security number, either for the same student, which would be a duplicate entry, or for somebody else. So I have to maintain that uniqueness. Sometimes the keys are two columns. Usually they're one. It's best to have them be one, but they can be two and occasionally three columns. So you can have multi-column keys. That's not impossible. It's not very common, but it's not very common for most tables. All right. So which of these are a good key to identify a person? And you should pause now and take a look and think about which one. Is the last name for the students at university good? Social security number, phone number, address. Which of these can be shared? Address and phone number. Which of them would, let's say, likely to uniquely identify a person? Okay, so, and then come back. The answer is really the social security number. That's the only one. Last name of the university or a phone number. This might work, although you get multiple people sharing a phone number. It doesn't happen that much anymore, especially in this era of personal phones. So maybe could use the phone number, but not the address, right? Multiple people can live in an address or address and phone number. So anyway. All right, a table join looks something like this again. So I have here code A and code B. They have different names. And again, there's this idea of matching from one to many. And what do I mean by one to many? Well, there's only one and only one entry of the key value towards here. This is a foreign key, it's called. It's a key in another table, a column in another table. So this X can match that X, and it can match that X. And what I'm going to do is copy these values and these values and put them in the new table. So the 1 FR 1001 here, and the AG and 1 here from that first row, and then the X, which is the matching. And I have another X then. This goes the AG and the 1, and the 2GM and 1001 here. So I'll go on down with every match, right? So the Y to here gives me 1. The X to here gives me 1. The Z to here. And notice that there's no Q's, and so no Q shows up here. Right? This just doesn't have a match. It gets dropped off. So multiple matches are fine in this direction. But if I don't have a match for the key, then it gets left out in this kind of join. This is called an inner join. I'll talk about inner and outer joins. Now, not all systems do this. Some systems by default do an outer join, which means I'd have the FPQ and the 10 here for these, right? FPQ and 10. But I would not have any values here for those things that came from the table A, right? Just because there's nothing to match, there's nothing that goes there. That's called an outer join, right? So again, building a join, this goes through it. Right, here's the X, matches the X. This just shows what we did. So for all the X matches, I'm grabbing the AG and the 1, and those are here. Then the values that I find in the X are here, the 1FR 1001, the 2GM 1001, the 4FR 1001, and the 6AG 1001, right? You can see that this is the key of this table. So you typically join from a key or candidate key to another column in a different table. You often don't join key to key. Sometimes you do. But this is a key for this table. It's good to use a key or a candidate key in the source table to point to the other direction. Right, here's the Y is only matched to one location, and the Z only matches to one location. Right, and so off we go. And here we have then this completed table. Oops, a little error there. The Z should match actually up to this one to give the AG and the 999, not the FR. But anyway, you get the point. So this is a one-to-many relationships. So I got to really, really stress that. One and only one can match one or many in the target. I want to make sure I go in this direction. If I were to try and join in this direction, it wouldn't work. Right? That's many to one. I want one to one or one to many in relationships in my data. Okay. You have to make sure you do that. The most common mistake rookies make, folks make that haven't been thinking about this or working with it a lot, is joining in the wrong direction. Right? So here's a well-behaved join, right? This is an XYZ, and I'm joining in this direction, joining by type, A, G, GM, and FR. To here, I'm joining in this direction. Then I get a output that's basically matching. All the AG, GM, and FR go one to many. The same thing here when I join on batch to batch. So this shows I can do joins to different columns from different tables, and that's really the strength of this relational database, is I can have all sorts of different tables all joined into other tables, different kinds of joins for different folks. So these are all well behaved because there's a one-to-many or one-to-one match in my variables, and I get a well-behaved output. For every time I do this join with these tables, as long as this is a key, and this is the key, the source is a key, and it's pointing to a like type column, I'm going to get a join that works. And it's going to be the same join every time. Right? I call my target a foreign key, and the reason I call it a foreign key is it's often a key, usually a key in the table that's the source pointing towards it. Right? So it's the primary key for this parent table and foreign key for the child table, or primary key for the source table and foreign key for the target table, however you want to call it. So here I have a hunter table and a bag records table. Right? And so the bag records table might be the tag ID, right? So you go out, everybody gets given a tag if they're going to go hunt something in this scenario, and the tags are unique. So I set it up so each of the tag IDs are unique, or the DNR does when it passes them out, so they can basically have this table of all the things that were turned in as shot, as harvested by hunters. So you can see how this table is useful. People want to know how many turkey were harvested. You could go through and sort out and get rid of everything but the turkey, or elk, or ducks, or deer, or whatever. But you also might want to know something about the people that are hunting and what kind of things they're hunting. So you have a separate hunter table when they get their license. And you can then join the hunter table to the quarry table and identify who's or what kind of person is shooting what. Old people, young people, women, people in different parts of the state, where they're from, when they're harvesting. So the primary key joins to what we call a foreign key, right? You have to be careful in this, the hiccup in this unmatched codes. And so sometimes if I have an X, Y, and a W, and I'm matching over here, right? While joining by type, or I have this AG, GM, SP. Well, the SP doesn't match anything over here if this is my type to type. Right, so I'm not going to get this W code in one kind of join, that inner join I talked about, and in an outer join, I will. So you have to be careful and know in your processing whether your system is set up, or you can set an option to get the inner or outer join to give you the results you want, give you the results that your analysis needs. So you might want information on the records even when there is no match, because there's information in these parts you're going to carry along. Or you might not be interested. You only want, in our bag records table, you might have a hunter that didn't shoot anything. Well, you don't care about that hunter. In your analysis, you're not going to want to carry them along. Whereas in some other analysis, you might be looking at, well, what's the rate of success? Well, you want the hunters that got tags and didn't get anything. So the analysis determines whether you want an inner and outer join. Either way, you don't want to join in the wrong direction. I don't want to go from the many, the foreign key, to the candidate or primary key. If I join in this direction, I'll get ambiguous results. I'll get results that depend on how the data were stored, or the system's operation that day, which is usually never what you want, right? So the incomplete match, if we lose the batch info, we call it an inner join. If we keep it, the missing stuff, we call it the outer join, right? So there's those two versions, right? So here we have that inner and outer join. In this case, we have an outer join, you're saying we're basically keeping along the information that doesn't have a match, and we're losing basically the information in the columns here, right? So in an inner join, we discard the things that don't have a match. So the inner joins are the same size or smaller, usually smaller. If everything matches, they're the same size. If there are any unmatched pairs, you get a smaller table. And you just have to know which you want. Your analysis will define whether you want to keep this unmatched information or throw it away. Just sometimes you can get the wrong results if it gives you one and you're expecting the other. The disaster is this joins in the wrong direction, a many-to-one or many-to-many. And that's because you get ambiguous results, right? So here if we join in the wrong direction from here to here, there are multiple FRs that can match this value. So I don't know which of these FRs to match, right? So here I have this many values of FR. I have a bad key where I'm doing a join. So this non-key column in a join, a many-to-one, in this case it's many-to-many, I don't know which FR to match to which FR. And the state of the system decides which is going to show up here. And that's never a good thing, right? You don't want ambiguous results. So you got to make sure of two main things in a join. One, that your primary key is your source, that you're only using a primary key as a source. And then that you point in the right direction when you have a foreign key. Don't point from the foreign key to the primary key. Join in the direction from the column with the primary key to the column table in the foreign key. Because you could have a good primary key, this isn't. But if it were, and you were to join in the wrong direction, you're still going to get ambiguous results. So again, be really careful of that one, right? So things to remember about relates, you need keys in both tables. A one value source table, candidate or primary key, to many in the target table, foreign key. So one to many joins, or it can be one-to-one, that will work also. Many-to-ones almost never work. Missing values in the source typically result in null entries in the join table. In these relates, this is one thing I haven't covered, they're usually virtual. You don't actually copy any of the information. The data don't actually exist together. It's really just a bunch of indexing. The relational database management system usually looks at the data you have, does your join, and then displays the data from both tables together. You're not actually copying or moving the data around. So if you want those data to be permanent, you have to usually do another step, copy the new data into a new data set. So copy that join. Now in many databases, all you're saving are the instructions on how to join things. You're not really saving the new data. But in some analyses, especially if you're going to transport or give the data or export it to something or someone else for further analysis, well then, of course, you want to make a copy of those data. So that's the main things about joins or relates in a nutshell. One to many, make sure you do them in the right direction.